Final lesson of Unit 2, kind of a doozy, but if we take it piece by piece, we should be able to wrap our brains around it. So let's take a look. Tangent and inverse tangent. We're going to start with tangent. What the heck does the graph of tangent look like? Now I've kind of moved ahead a little bit, but I'm going to explain why I've got this line right here. But what is tangent? Tangent by definition is opposite over adjacent. So what you get used to after you've been around math a long time is what can't happen. Well, you can never have a 0 in the denominator. So the question is, where does the adjacent side ever disappear? This goes back to our quadrantals. Notice this is our adjacent, this is our hypotenuse. So 0 degrees is not where it disappears. If we go up to 90 degrees, notice I have a line right here at 90 degrees, pi over 2. That's a huge hint, because my adjacent side is right here. In other words, it disappears at 90 degrees. So 90 degrees is what's considered something that x can't be, because we would have an undefined situation there. But it also happens at 270, because if my spinner goes all the way to 270, there's my adjacent side again. So 270 is not part of my domain. So 270 and 90 can't happen. These are considered asymptotes. They're a section in the graph that x cannot cross. It's a part of the graph that just doesn't exist. So that's why you have an asymptote right here. But we also checked out 270. It's right there. Now, because this is a timed videotape, I'm just going to tell you, negative pi over 2 would just take you to 270. So we'd have another asymptote here, and every chunk of pi, we would have another asymptote. So that's how you would get started. Now, how do we fill in these missing pieces? I'm going to pick this window right here and start plugging some things in that kind of identify some major points. The most obvious is, let's put 0 degrees right here and type it in. And so we would take our calculator, we'd go tangent of 0 degrees, and we'd get 0. So if I plugged in this little thing right here, x, and then y, 0 degrees, I'd get 0, which means it's right there. Now I'm going to plug in 45 degrees, negative 45 degrees, and see what happens. Tangent negative 45, and I get negative 1. So negative 45 degrees, I get negative 1. I want to see what happens when I go out this way. Well, it takes me down 1. Now what if I go to negative 89 degrees? Tangent negative 89 degrees is negative 57. So negative 89 is negative 57. As you can see, it's going to come like this, and it's going to try to get near it, but it's starting to go down. Now if I looked at the positive 45, tangent of 45, I get a 1. So now I go out to 45, and I go up 1. And if I typed in 89 degrees, I'm just going to get positive 57, which means this thing starts screaming up really fast. And there is one chunk of tangent. Now the thing is this just repeats itself over and over and over, forever and ever. So then the math asks us to answer some questions. What's the domain? Well, what they're going to ask, like, what can x be? Well, we know what x can't be. So basically what they're going to say, let me pause this a second to find out what kind of language they're going to use for this. Okay. So, like I said, we're going to pick this window, talk about our domain, just this window right here, and we're going to say that x cannot equal negative pi over 2, and it cannot equal positive pi over 2. Now here's the twist. They kind of say, all right, what's the domain of the whole thing? Well, what we need to see is 3 times this would also have a domain. That's an odd number. And then this would be 5 pi over 2, another odd number. So we're going to say generically that it also is n times pi over 2, but if n is an odd number, this is what x cannot equal. So this captures the whole graph, infinitely this way, infinitely that way. Now what's the range? Well, as you can see, the range goes down forever. And so y is greater than negative infinity, less than infinity. Okay? So, let me see what they're asking next. Okay, so they're asking for the x-intercepts next. And they might say all real numbers for your range also, because y goes down forever and it goes up forever. So that's all real numbers. X-intercepts. Well, as you can see, you got 0, pi, this would be 2 pi. So, so the x-intercepts, we start with 0, and then pi, and then 2 pi, and then we could go negative pi, because that would happen right here as well. So it goes like this. And you can see that any n times pi would be, and this has to be a whole number, positive or negative, would be our x-intercepts, because it happens an infinite number of times. Asymptotes. Well, as you can see, we've got an asymptote right here. All vertical lines are x equals. So that's pi over 2, negative pi over 2, and then we got another one at 3 pi over 2, and then negative 3 pi over 2. So we could say plus or minus pi over 2, plus or minus 3 pi over 2, and as you notice, 5 pi over 2. And so we'd go plus or minus 5 pi over 2. And then to capture all of them, we'd say n pi over 2 plus or minus, but this has to be an odd number. So this explains all of them. This explains specific ones, which leads us to our formula. Okay, let me pause this a second. All right, here comes the inverse of tangent, which if I do a good job, it'll make sense, but I could get tongue-tied and brain-tied as I just did. So, first of all, y equals tangent of x. We just showed you that this is what it looks like. Now, what we have to try to find is the inverse. Now, don't forget, the inverse function is where we switch the x's and the y's. Keep that in mind. We've done these before, but now we have to apply it to tangent, which is kind of challenging, very challenging. So, taking a look at this, I'm gonna first start with the asymptotes, because even the asymptotes have an inverse function to them. Notice this is x equals pi over 2, and remember, pi over 2, if I looked at it, I'd say x is 3.14 over 2, which is approximately 1.5-ish, 1.57. So when we take the inverse, we switch the y's and the x's. So we're going to say, hey, so our new asymptote is y equals 3.14 over 2, which is approximately 1.57. So that would be right about here. And my drawing, I got a little curvy, but you guys get the idea. All right, so there's one of them. But then I also have x equals negative pi over 2, which is negative 3.14 over 2, which is negative 1.57. So my other asymptote would be approximately there. And I know this is going to get very messy by the time I'm done. But what we're going to do is we're going to take this and find the inverse by switching the x's and the y's. So notice, over here, this point right here, if I take tangent of 45 degrees, I'm going to get 1. Don't forget, that shouldn't be a shocker, because if I have a 45, 45, 90, tangent is opposite over hypotenuse, so it's always going to be 1. But we're going to turn those around, and now we're going to say, all right, switch this with this, and we're going to say, all right, tangent of 1 is going to have to be pi over 4. Now, so now we're going to switch these around. This is my new x, this is my new y, but we have to kind of convert it so it fits into here. So that means if I go right 1, which remember, pi over 4 is the same thing as 3.14 over 4, which is about 0.75. Pi over 2 is 3 over 2, which is approximately 1.5. So I have to move to the right 1, which would be right about here. And then I have to go up pi over 4, which is 3.14 over 4, which is 75.75. So it'd be right about here. Now, if I take this guy, 0, 0, and I flip it, good news, that doesn't change. And now I need to look at this. If this is true, then for the inverse function, I'm going to get tangent -1 equals negative pi over 4, which means if I go left 1 unit, which is right about here, because this is 0.75 negative, this is 1.5 negative, so right about here is -1, and then I go down 3.14 over 4, which is approximately negative 0.75 again. So I go over here about 1, go down there, and I can see that this thing is going to go like this. Now, how good is my drawing? Not bad. This thing should flatten out a little bit. And I don't think they ask us for domain and range on this one, but let me double check that. Okay, I don't know if they did or didn't, so let's just talk about it. Domain, well, how far left does it go? How far right does it go? As you can see, it's all real numbers because it goes right and left forever. What about the range? Well, the range, remember, it tries to get up to 1.57, it tries to get down to negative 1.57. So that would be y is greater than, but not equal to, negative 1.57 less than positive 1.57. Where's the x-intercept? Well, it's the same thing as the y-intercept. So the x-intercept and the y-intercept would both be 0, 0. There, throw that in for free. I don't know if we needed it, but there you go. I got one more thing to show you for this lesson, and then we'll be done. All right, last little section here. So, for any function, that means any function, to even have an inverse, the function, but we're talking about tangent now, must pass both the vertical and the horizontal line test. So, by memory now, we know that in this window, it looks something like this, and then that just keeps going forever and ever and ever and ever. And it also happens over here, there. So, that should start being a parent function where you see tangent, you go, I know what that looks like, but does tangent have an inverse? Well, if I did the vertical line test here, it passes, it passes, it passes. With the horizontal line test, it fails because it would hit in an infinite number of places, so it failed. So what they do to tweak this is they say, okay, let's let the domain of tangent be x is greater than negative pi over 2, less than pi over 2. So what they're saying is, forget about all of these possible windows, and let's just concentrate on that window. Now they could have picked this window and that window and this window, but they stick with this one because it comes off the center. So, in this window, tangent has an inverse function. So that's why the domain for tangent, when calculating the inverse function, can only fit in that window. That finishes today's lesson. That finishes the lesson, final lesson of Unit 2.